The Binomial Theorem. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. A binomial expression is a sum or difference of two terms. Bracketed expressions such as a plus b raised to the power of 4 are also called binomial because they are two terms in the bracket. For example, these expressions are all binomial expressions because there are two terms in the bracket. Any expression of the form x plus y raised to the power of n is called a power of a binomial. In this video, we will find a formula that gives the expansion of x plus y raised to the power of n for any natural number n. All binomials raised to the power can be expanded using the distributive law. Let's consider the following algebraic expansions using the distributive law. The distributive law states that each term in the first bracket must be multiplied by each term in the second bracket. The next binomial can be expanded using the previous result. The next most complicated binomial can be evaluated using the previous result. Although in principle it's easy to raise x plus y to any power, to do this, we multiply the binomial by itself repeatedly. Conversely, we can see to raise a binomial expression to very high power, the process is very cumbersome. But if we look closely at each expansion, we will see some patterns. Pay attention. From this point on, you should already know Pascal's triangle. If you don't know Pascal's triangle, you should watch this video before continuing. To find a pattern, we write down some binomial expansions. Pay attention. The first pattern is the coefficients of each term are all numbers from Pascal's triangle. The second pattern is, as we move through each term from left to right, the exponents of x decrease by 1 from term to term, while the exponents of y increase by 1. The third pattern is the sum of the exponents of x and y in each term is equal to the exponents of the binomial. For example, in the expansion x plus y raised to the power of 3, the exponents in each term add to 3, as well as in the expansion of x plus y raised to the power of 4, the exponents in each term add to 4, and so on. The fourth pattern is the number of terms is 1 greater than the value of n. For example, when the exponent is 2, the expansion has 3 terms. When the exponent is 3, the expansion has 4 terms, and so on. We can use these patterns to expand any binomial. For example, let's expand x plus y raised to the power of 5. The exponent is 5, so the coefficients will be the fifth row of Pascal's triangle. So this expansion will have 6 terms. Then we write down the expansion by remembering that for each new term we decrease the power of x, this time starting with 5, and increase the power of y. Expand this binomial. We rewrite the binomial in this form and substitute 3x for x and minus 2y for y. The exponent is 4, so the coefficients will be the fourth row of Pascal's triangle. So this expansion will have 5 terms. Then we write down the expansion by remembering that for each new term we decrease the power of 3x, this time starting with 4, and increase the power of minus 2y. Although Pascal's triangle is useful in finding the binomial expansion for small values of n, it would not be recommended for large values of n because of the need to generate a large number of rows of the triangle. From these patterns was developed a formula for expanding any binomial. This formula is known as the Binomial Theorem. The Binomial Theorem can be written as follows, where n is a positive whole number. We can also write the binomial theorem using sigma notation. Now let's see how it works. Use the binomial theorem to expand this binomial. We write the binomial theorem. Then we need to identify the two terms in our binomial, the x and y positions of our formula above, and the power n for which we are expanding the binomial. The two terms are 2a and 3b, and the power is 6. So we substitute x for 2a, y for 3b, and n for 6. The values of r in the coefficients will start with r equals 0 and increase by 1 in each term. The last term must end with n equal to r. In this case, n equal to 6 and r equal to 6. From the Pascal triangle, we know that the first and the last coefficient is equal to 1. Since any value raised to 0 power is equal to 1, we can simplify terms with 0 powers. Let's rewrite that expansion. We can find the coefficients of the other terms by using this formula. It's a good time for you to find these values with your calculator. Lastly, all we need to do is multiply and simplify each term down to its simplest form.